So I did mention to you that we reorganized some material
Okay.
and that we had an assessment that I was going to post online for Module 3. As you can see, it's not out here yet. But before the day is out, I'm going to post the Module 3 assessment. And you'll have a couple of days to get it done, and then a pre-recorded video of the item analysis so that you can reconcile. And I just wanted you to be aware to watch out for that. So you're going to want to go ahead and, finish any final review that you have for layer 3 routing and IPv6. Up to this point, we've talked about the origins of networking and network essentials. In Module 2, we talked about layer 2, the physical layer or media link layer, where the MAC address resides and where we work with frame. The datagram, the chunk of digital information is called a frame. So on layer 1, we're dealing with signals, and layer 2, we're dealing with frames. In layer 3, we're dealing with packets. And so all of Module 3 is really about IP networking and routing, internetworking, and that's what we're dealing with in Module 3. Module 4 has to do with the upper layers, transport layer, application layer. So we're dealing with a lot of the software issues in the last module here. So what we wanted to do was to continue with our introduction to applications and network administration and management. I have a quick question I'd like to put in chat. And what I'd like you to do is to respond to me only. So I'm going to type in chat. I'm going to say true or false. A smartphone can be a server on a network. True or false? And what I'd like you to do is to hit the pull down in the chat and respond only to me. So you either say true or false. And what we're seeing so far are some interesting answers. We'll wait just another moment, but if you could open up chat, respond only to me so that only I see your answer. True or false, a smartphone can perform the role or can be a server on a network. And of course, we're dealing with module 4. So we're talking about module 4. So let's take a look. We do have some trues and some falses for an answer. One of the things that we wanted to stress about client-server networks is that the term server doesn't apply to it doesn't have to do with the size or type of device. So we're not dealing with the size of the device or system. A server in a data center would have to do with hardware, but this course is about networking, right? So when we talk about the client-server model of networking, we have a device or a system that's connected to the network, and it's any connected host that is listening for resource requests, and it responds to provide those resources, either services, data, or both. Now, what I'd like to share with you next is a diagram of how a server would establish a socket. So a socket has two components, and a socket includes two pieces of information. So when a socket is created, A socket uses the IP address of the host or server and the port number that's used to create the socket. So the definition of a socket is it's a resource that is formed to listen or to exchange data on a network. You can have a client socket and you can have a server socket. And that socket is created with a known port number, a registered port number for a given application, like a web server, and it's bound or connected with or associated with the IP address of the host. So this is a server socket. I want to show you an example of what happens on a server when, let's say, a web server or an email server decides, okay, I'm going to offer web pages, or I'm going to transport and store email messages. So the web server or email server creates a socket. It uses its own IP address, and it combines it with the port that is expected on the server side for that particular service or that particular application. In this case, port 80 is for web servers. In the other case, for email, it's port 25, right? So the public IP address for the server is combined with the port 80 for web service or 25 for email service. And once the socket is formed, those two components are bound together to the service, right? And the service starts up and it's in listening mode. So the first task of the service after it binds the components of the socket together is to listen for a request. Now, a request is going to come in on the network, and this server is listening for a request. Now, if somebody makes a request, hey, I'd like my email. Hey, I need this web page. The server is going to hear the request or receive the request on that port, right? Now, how does that server know it's getting a request? Well, clients that need the resources know to look on a specific port number. Because they're registered for a given application, if I'm going to need a web page, I'm going to look for port 80, or if it's an encrypted web page, if it's a secure web page, it's going to be 443. If it's email, I'm going to be working on a different port, right? So we register these things. These are determined by an authority, the Internet Naming Authority, right? IANA. It determines which port numbers are used for what purposes, okay? So we've already told you, if you have webmail is on port 110, right? Telnet is a way of remoting in on a terminal or a prompt to control a machine. If time synchronization between the clocks on systems, that uses port 123. Kerberos has to do with Active Directory domains. That's something we'll talk about in later courses. SQL is a database application, and it uses port 1433 and port 1434. Now, we say these are scary ports because, well, hackers love database servers because they have all this juicy data neatly organized in a very understandable format, and it's tightly condensed information, and it's very rich information. And so it's kind of like a gold mine of data. And so hackers love to hack database servers. But the database server is sitting on a port 1433 and 1434, And I say not really. I mean, it's not really scary in the sense that there's always something evil. Usually there's something good happening with a database server. But the truth is, you have these connections. So a client, let's take a look at this. Can everybody see this?
Yes.
Yes.
Okay, so let's pretend I have a web server and I want to use a web server that has a padlock on it. By that, I mean this. Everybody see my screen?
Yes.
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 So when I connect to the Blackboard server for UVI, that Blackboard server is not exposed on the open internet like any other web server. It's encrypted. That's what the S means, secure. So it's secure, which means that it's connecting on port 443. And it's using a special method called TLS, transportation layer security, okay? When we talk about port numbers, we're talking about layer 4. When we talk about transport, the sending and receiving of those packets, now we're away from layer 3 and we're talking about port numbers. And that's really important to understand. So let's say that we have a web server and it's a secure web server and it has an IP address of 146.226.24.10. And so it connects, it creates the socket, it binds the components together, it starts listening for website requests. And then basically what happens is that a client says, hey, I want to connect to Blackboard. Well, let's say on a UVI Blackboard, right? So in DNS, in the domain name service, that's another special service, you type in blackboard.uvi.edu, it looks at the uvi.edu name, the domain name, and it says, aha, it's this IP address. And because we're connecting to a secure web server, your client says, okay, I'm going to use 146.226.24.10, and because it's secure, colon 443. Now, the important thing to understand here is that when this client reaches out to the server, you have a socket on the server, and it's doing this. It's walking through these steps. And then when it gets a request, while it's listening, it accepts the request, and then it receives the request, and then it sends a response, and then at some point, it closes the session. And what are we talking about in terms of a session? A session occurs when two sockets are working together to form a session between two hosts. One is the server, it's providing resources and services. The other one needs the resources and services. Now, what am I saying? The server creates a socket to listen. This one creates a socket to request. So what are we saying? The process looks a little different. It's shorter. You don't have to create and bind a socket to listen and accept requests. These first steps are missing. But you do have a socket. You do have a socket, right? That is created on the client side. And the important point to remember is that the two of these work together. Now, a session is defined by both the client and the server sockets together. What am I saying? If my first client says, aha, I want to go to Blackboard, it creates the session, right? And it makes a request and the information starts to exchange back and forth. This session is defined by the pair of sockets. We have the server socket and we have the client socket. But I want you to see what happens. And this is really, really important. This server is capable of responding to many, many clients simultaneously. Everybody knows this, right? I mean, when you connect to Amazon, you realize that on the same Amazon server, there's probably 1,000 people, right? And have you ever wondered how Amazon keeps each session separate? How Amazon knows that your session is different from everybody else's? Well, let's look at client B. On this side, client B, let's say a second person says, oh, I got to get on Blackboard now. And they have a different IP address, right? You'll notice that this client has a 45 address, right? 78.45. Whatever, blah, 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 blah. This one has a 78.44 address. So this one's a different IP address. This client grabs a higher level port number, right? Now you'll notice these high level port numbers, that's typical of a client. So whenever you see like a 4-digit or a 5-digit number, that's usually a high 4-digit or a 5-digit number usually means, okay, that's the client. And if it's requesting from the server, the port numbers that are used on the servers are lower. So just remember, low port numbers, server, high port numbers, client, okay? And these are random. So over here is client B. Everybody with me so far?
Yes.
All right. So we have a session going on between these two. And this server says, okay, I have a session defined by these two IP addresses and these two ports. And it looks like this, right? And it says, okay, this is the first session I have going. Now along comes client B. It has a different IP address. Now, it's supposed to pick a random high number port, but let's say just by accident, it picks the exact same port number as client A. It still has a different IP address. Its IP address is still different. And because it's 44 instead of 45, the socket for client B is different, which means when client B requests the information, server 1 is still listening. Server 1 responded to client A, but then it's listening for the next client. And when client B comes along, it says, hey, I also want to get on Blackboard. And I'm at 78.44.96.174. And I'm using a different port number, right? I'm going to pick a random port number. So my socket is 78.44.96.174:59253. The server says, okay, let's start a session. And the session is formed this time with this set of information. Now notice the root, the server information stays the same, but because the client side is different, the client socket is different, and two sets of unique sockets make a session. The session between client A and server 1 is different than the session between server 1 and client B. And that's because some of the numbers are different. What are we saying? Server 1 can handle thousands or even millions of clients, and no two sessions are identical. Does this make sense?
Can you go over it one more time?
Okay. Well, I am recording this, so I can put the recording out on Blackboard after we're done, but let's walk through it again. A session is defined by the two sockets, one on the client side and one on the server side. If we have a server that's listening, it's started up a socket and it binds the components together and it starts a service to listen for requests for resources and data. Eventually, a client will attempt to request the resources or data, okay? And then the server will accept, and then there will be sending and receiving of information between the client and server, and then it'll close, okay? Now, it's important to understand that every session number is different because each client has a unique IP address that's different from other clients. And even though they pick random port numbers, they usually have a different port number, right? High numbers. High port numbers are called ephemeral ports because they're only used for that session. The server's port number is a registered port number. It doesn't change because everybody knows if I'm going to get something off of this server and the web server has a padlock, then I'm going to use port 443. So this client says, hey, I'm going to connect to port 443 and ask for resources, request resources. Along comes client B. Client B says, hey, I want to ask server 1. But when the session is formed between client B and server 1, because the socket for client B is different, the session identity or the session that's formed between server 1 and client B, it has different criteria. So the server is capable of having a session with client A, client B, client C, client D, client E, client F, all the way down the line. The client sockets are all different. And when you take a server socket and a client socket together, they each create a unique session identity, right? Does that help?
Yes, thank you.
You're welcome. Now,
I have a question.
yes.
All right, so you said that the server for each client does change along with the numbers, right? Would the notation change in that process, or would it stay the same?
That's a great question. So if the notation you're referring to is the session identity or reference, the answer is yes. The server information, the server socket never changes. It remains constant because the port, that's how when you go to a web server, everybody knows, hey, I'm connecting to this port. If I want something on a web page, I got to go to 80 or I got to go to 443. 80 doesn't have a padlock. 80 is unsecured, but it's still a web server. There's a lot of those out there. They just don't have a padlock, right? If you go to any other web server, because you're going to Google for your email, well, that's private. It's going to be encrypted. It's going to be secure. Oh, you're going to Amazon, you want to buy something, that has to be secure. Then you have a padlock. The padlock says, okay, I'm using a secure web connection and I have to do that on a different port. So that's why this number is different for secure web server, right? That remains constant, but because each session with each client identity is different. So the notation is different, right? So your sensibility about what you just asked is right on target. Each client is different, so each session that's formed with different clients is different. And that's because that session is identified by the combination of client and server socket information. So remember, there's a client socket and a server socket, and together they tell you what a session is. Okay. Now, we've explained that a socket is an IP address with a port. And we've explained about sessions. So we've talked about sockets and we've talked about sessions. And now what we want to do is talk about two special connections, right? We want to talk about connections. And you're like, wait a minute, isn't that like a session? Well, it turns out that there are two special protocols in the transport layer, one called TCP and one called UDP. And yes, they both use port numbers for specific applications. For example, I use DNS, domain name service, right? I configure a domain name server on my network connection when I'm connected to my Wi-Fi so that I know how to find things by name out on the internet. That port is 53. When my client is asking, hey, where's google.com? Where is facebook.com? Where is WhatsApp or Snapchat or Instagram.com? Where can I find that server? Instagram.com is translated into an IP address. And then a port is added if it's got a secure connection, right? So you have these common internet applications that use registered port numbers. But here's the thing. between a client and the server, there's always a session. And the session is identified by the sockets on the client side and the server side together, separated by a comma. But what's unique about UDP and TCP is that we kind of split internet applications into two major categories. Okay, those with connections, sessions that have a formal connection, that establish a formal connection, and sessions between a client and a server that are what are called connectionless. Okay, so this type of session formed with TCP, if it's a TCP protocol that forms the session on the transport layer, right? So you have the IP address on layer 3, and then you're connecting to a server, and the transport protocol says, yeah, I have to create a session, and I want to create a session with a connection that remains in place. I want to guarantee what flows back and forth. That's a TCP connection. If I have a session where I just have to deliver content, all I'm doing is delivering the goods. I don't have to hold hands. I just shake hands and then pass stuff, right? So what am I saying? When I'm doing email and web stuff, I might form a TCP connection. If I'm sending messages, I may form a session just to pass a message. But I don't have to sustain the connection between the client and the server in order to do this. For that kind of session, a connectionless session, UDP is the protocol of choice. Okay, so on layer 4, you have the TCP protocol. What do you have on layer 3? IP protocol. Together, when you're having a connection between clients and servers, you're using TCP IP. When you have messages or content that are passing in a client server session, but there's no sustained connection to guarantee delivery, then it's IP UDP, right? It's UDP IP. Everybody's heard of TCP IP. Just by association, you hear a lot of tech jargon. People say, oh, this is a TCP IP network. Well, it's an IP network. It's layer 3. It has IP network addresses. And half the time it uses TCP, sure, when a connection is required between client and server. But the other half of the time, it isn't. When is that? Oh, when I'm streaming a movie. Because, if one of the frames drops during the network transmission, my customer isn't going to know the difference because they see 30 frames a second. If a couple of those data packets drop, I don't have to maintain a connection to deliver the goods. Absolutely. I don't have to have guaranteed delivery. Okay. So let's go down to section C here and take this a step further, right? It's really important for you to review this information about sessions. Okay. So just remember that you have sockets. It's a port and the IP address, and that's for a single host. If you have two of them, one that's listening for resources and the other one that's requesting resources, you have a client server session. And then, of course, we talk about registered or ephemeral. When you see the word ephemeral, it means those are host ports and they're random. You should click this link, right? Here's the thing. UDP, you build sessions to exchange data. But the thing to remember is that TCP and UDP work in a little different case. So if you design a network application based upon the streaming or message paradigm, this is called the message paradigm. I'm gonna hook up, right? So I'm a client. I find a server that has resources. I'm gonna hook up. I'm gonna go ahead and create a session with that server. And what I'm trying to do is receive a message. Hey, I'm requesting my messages. I need some data. I need to know what the time is right now. Right? Oh, and if I don't get it, I'm just going to request it again. Okay. If you don't have to have guaranteed delivery, if you're just passing a chunk of data along, that's called the message paradigm. Okay. So what you're going to do is you're going to send messages, or you're going to pass some stuff, a stream of stuff, and the data is not guaranteed. Okay. The data is not guaranteed. So if you talk about YouTube, Zoom, or Netflix, right, and you drop a little bit of data along the way, people see a little skip in the YouTube video, but that doesn't mean that the whole YouTube video is ruined, right? So that's what a message, we're talking about message delivery. We're just talking about something that isn't guaranteed. Now, if you want a persistent connection with guaranteed delivery of packets, what's a good example of a session where you have to guarantee the delivery of packets? Oh, you're buying something or you're paying a bill with your bank. Is everybody with me?
Yes.
And let's pretend that you're using your checking account with your online banking. Do you think it would be a good idea to use a protocol that didn't guarantee the delivery of your account number? The short answer is no, you would not. You would not want to have an application on a network built between clients and servers where there was no guarantee. Sometimes, depending on the purpose of that application, you want to guarantee the delivery of packets. You have to guarantee the delivery of packets. So you want a highly structured, securable session that remains connected. In other words, your session has a persistent connection. So UDP is connectionless. We're not forming and maintaining a connection the whole time the client and server are talking. We're just passing stuff along. We're just passing a packet of data along. And if it doesn't get there, we're going to request another one. That's UDP. With TCP, we're saying, oh no, we got to make sure all the data gets through. In fact, we're going to make sure that each chunk of data is numbered. And when they go through the data network, when they get to the other end, they're going to be reordered in their number. Okay. So when we say guaranteed delivery, we mean integrity of the data as well. That's TCP. Okay. 90% of developers choose TCP. Now, you'd probably think, okay, it's just that simple. I'm always going to use a connection. I'm always going to work UDP. Well, there are some times where data exchanges with connectionless sessions is actually a lot more efficient. Like the DNS stuff. Hey, where's Google.com today? Hey, I'm talking to you. Hey, I need Google.com. You might need to make more than one request, but that server is gonna respond to the session and the request. And even if there isn't guaranteed delivery, you're going to get a response, right? So if you wonder how is it that DNS servers can fuel the entire internet with billions of users, it's because it uses UDP. So what are we saying? Let's just kind of recap, okay? If you're using a UDP protocol to create a session between a client and a server on a network, meaning a host that's providing resources and data, and it's listening to respond to those requests for data and resources, then that server is going to be opening the socket and it's binding to a listening service, and that service is waiting for somebody to make the request, right? And If you're using UDP, the session is formed from the client to the server. That's what we mean by end to end. But it is connectionless, meaning we don't establish protocols to guarantee the packet delivery. We don't take extra steps to lock down the connection so it stays in place the whole time from beginning to end. We're just going to say, hey, you got something for me? Yep, here it is. And it's just very short and very efficient. It's message-oriented interface. Usually we're talking about quick, short messages that can be resent if you don't get them. It uses a best effort semantics, meaning the algorithms for that protocol, for UDP protocols, basically do their best to deliver those packets in a UDP session. But if not all of them get through, that's okay. All right. Operating system independence, right? What that means is it doesn't matter what kind of operating system is in play on each host. The server and the client can have different operating systems. They don't have to be both Windows machines or both Mac machines or both Linux machines. But notice that there's no congestion or flow control. So there's no control over the flow of information, the order that it's assembled, what happens when there's congestion, is it retransmitted so that we get all the packets? None of that's in play for UDP. Arbitrary interaction means that you can fire off requests and responses at any point, okay? So a client and a server can just arbitrarily say, hey, I'm talking to you, anything yet? Are we there yet? Anything now, right? That's what we mean by arbitrary. Any questions about UDP? Okay.
No questions.
Now, what I want you to understand is that when you're creating network applications on layer 7 or layer 5, it's important to choose which transport method, which protocol you're going to use on the transport layer, layer 4, the layer that sits between application layer and network layer. All right. TCP, end-to-end communication. It's a connection-oriented paradigm, which means, okay, I'm going to start a session, but it's not just going to be any like haphazard session or random or arbitrary session. I'm going to establish a connection, a formal connection. I'm going to say, hey, this is server so-and-so. Well, this is client so-and-so. Hey, let's lock hands because we got a lot of data to exchange and we got to get it in the right order. You got it. So they have extra protocols to establish a session that maintains the connection between client and server constantly during the session. Point-to-point connections are created between client and server. There's complete reliability. When something is sent from server and client, either way, from client to server or server to client, that data gets to the other side and it's guaranteed. Full duplex communication, sending and receiving at the same time. So it's not like, oh, I'm sending, well, all right, now I'm waiting. Okay, I'll respond, I'll send back, right? That's what happens with UDP. With TCP, it's like, no, we're simultaneously sending and receiving data constantly. There's a streaming interface, right? The thing that I want you to understand is that these ports come back in a big way with firewalls. We're going to talk more about firewalls when we get later in the module. We're going to talk about basic security, network security. But firewalls will allow or disable traffic based on the port and the protocol. So a firewall can say, okay, I'm going to block TCP port 80. I don't want anybody trying to connect to me as if I'm a web server. And you might ask, why would anybody with a Windows laptop or a PC have to worry about that? It just so happens that some printer software applications that come with printers you can buy in any store. When you install the software, it sets up a web server on your laptop or your PC. Let me say that again. Some popular brands of printers, when you buy them so that you can print documents and pictures at your house, when you install their software, it sets up a web server on your laptop or your PC. Yeah. And that's because it wants your PC or your laptop to be able to provide a service to manage the printing and scanning, right, of photos and documents. Kind of makes sense. Every time you hear the word server, you're like, okay, I'm providing data or resources of some type. Most people don't realize that they have a web server running on their PC or their laptop. But if you have a firewall rule that says, yeah, I'm just not listening on TCP port 80 from anybody, then that closes off all that stuff. So that's the piece of this I want to share about firewalls. Are there any questions before we close for the day? Does everybody understand the differences between on the transport layer when we're transporting data? Now we have two hosts with two unique IP addresses. They want to exchange data. We're talking transport level action now between two systems. One's a client, one's a server. That transportation of data occurs on the transport layer. And that transport layer typically has two different types of protocols. One that's just, hey, I got a message for you, and it's arbitrary. You kind of check in with each other back and forth randomly. The other type of session that can be created in a transport session is connection oriented. There's complete reliability. There's better communication back and forth, but there's a much more complex protocol that has to happen for TCP. So if you're ever working with an app and the data has to get from point, it has to get there reliably. If you have to have reliable communication, you have to go TCP because it involves a connection, because it has error control. It deals with the issues for congestion and flow control. Any questions before we close for the day?
About this, no, but I still have something I wanted to talk to you about.
Okay. I'm going to go ahead and close the session real quick. And then if you would rejoin, I'll let you back in there.
Okay.
Yep. All right.